In this video we're going to be investigating a problem with this CanoScan N656U flatbed scanner. Here's the problem, and it's only just started happening a few days ago. If I plug the cable, the USB cable, into the back of the scanner and let the computer recognise it, we get this little problem. It seems that the scan head is trying to drive itself into the end and not stopping. Now let's just switch it off for a second. In order to disassemble this unit, we have to first of all remove the lid, and that's a little more difficult than the workshop manual makes out. The workshop manual tells you to take this section here and flex it so that the thing comes off. You do have to flex it very hard, so much so that you think you're going to break it, but you won't break it, or at least I didn't. So let's go ahead and do that first. I'm going to push, I'm going to have to put the camera down. I'm going to have to push with my thumbs against there and against there with my other thumb that's currently holding the camera, and flex this whole lid until the top comes off. So having done that, we'll set this lid aside and continue to disassemble it. Now what we need to do now, and I've already done this so it makes it look like the job's really easy, is we take this section here where there's a little bit sticking up and we just clip this up. Now this is actually glued down with double-sided tape, so you're going to have to pry it very gently all the way along to get it off. It's coming off easily here because, as I say, I've already done it and removed the double-sided tape. So remove that side and then the same on this side, and it just fits under there with a little hook. So we'll set that aside as well, and then what we can do is we can pull this section forward and raise it. I'm going to have to put the camera down again. So raise this glass piece up and move it forward, and let's just set that piece aside as well. And what we're going to do now is we're going to plug it in again. Not because we expect a different result, but because now we'll be able to see what's going on a little more easily. So let's plug this in again, let the computer recognise it, and here we see the same problem again. Now before we do anything else, let's just remove these little white pieces, because one, they're very easy to lose, and two, they get totally in the way. One's already fallen out. Look. Right, now what we're going to do is we're just going to take this scanning head and move it along, and you can see what actually happens is it moves nice and smoothly without that rattling noise until it gets to the end. And when it gets to the end, we're back to that silly rattling noise. Now it looks like what's happening is that the electronics on this scan head doesn't recognise that it's getting to the end of the travel, so that's why it's continuing to try and drive. And if we look here, there's a little opto coupler there, which when it reaches the end, it's interrupted by that piece of black plastic, piece of grey plastic. Right there. See, that piece there. And that should go between the slot of that opto coupler, and when it interrupts the light beam, it should shut it off, which it's not doing. So let's depower it again and proceed to disassemble it even further. So what we're going to do now there's no power on it, so we're just going to move this head a little way along, and we're going to just raise that off there, and we're going to disconnect this electrical connector as well, and set that aside. So that enables us to lift this whole piece up, and if we look, No, what we're going to do first actually is we're going to undo this spring here. So let's just get a flat blade screwdriver under there and take that off, and that enables us to lift this head up completely. The way this goes, we'll remember this in future for when we put it back together, is that comes down there, goes round there, and then back down there. Okay, and down there, and that's how it drives. But for now we're going to remove it altogether and set it aside. So now we have the scan head as a separate piece that we can look into. Now, looking closer at this opto coupler, you can see it's labelled Q4, and if we look on the other side of it, these are the connections to it, and you can see that there is, let's just set this down a second, you can see that there is actually, and I've checked the schematic in the workshop manual, this is a power supply here, 5 volt power supply. It's actually about 4.5 volts, which goes through this resistor R26 and then goes into the LED side of this opto coupler. So that's the anode of the LED, and then the other side is grounded, it's connected to this ground plane here, and the other side, the phototransistor, that's the emitter, which is grounded, and this is the collector, which is effectively the output. So what should happen, of course, is that when the LED is on and the light beam is not being interrupted, this phototransistor turns on, and this voltage here should be low, and that's obviously what is read by the chip to continue to move the scan head. Now, when the unit reaches the home position, the black piece, I keep calling it a black piece of plastic, the grey piece of plastic that we looked at a moment ago interrupts this light beam by going in between there, blocks off the light being received by the phototransistor side of this opto coupler, switches it off, and then this voltage here should go high, well, high to about 4 volts or so. Now, measuring it, it's not. It's staying low the whole time, so the electronics which monitors that is under the impression that it's not reached the home position. That's why it continues to drive. So what we're going to do is we're going to remove this opto coupler. Okay, I've now put the thing back together, but with the opto coupler removed from the circuit board, which did fit there. I've also removed capacitor C41, which is placed across the emitter and collector connections of that transistor. So let's see what happens when we plug it in now. With the phototransistor missing altogether, there's nothing to pull down that voltage that we looked at that goes to the chip. So it should be in the state which corresponds to the light beam being blocked. In other words, it thinks it's at the home position. So if I plug it in now, guess what? It moves in the opposite direction to how it was moving before. Let's just depower it a second. And what I've done now is I've put a wire link across the connections of the emitter and collector of that phototransistor. So now simulating that it's in the position where the light beam's not being interrupted, which is the state we were in before. If we plug power in again now, it moves in the opposite direction again. And if I remove that link, it moves in the other direction. So that suggests that everything downstream of that photo coupler is working correctly. When it gets to the end, you're going to have the same problem that we had before, but in reverse. It's going to try and drive it in that direction towards that end. Now let's just switch this off for a second. So what does that tell us? It tells us that either the optocoupler is bad or that capacitor that I also removed is bad. So let's start by replacing the optocoupler itself and leaving the capacitor out of the equation. Okay, we've put that photosensor optocoupler back in, but not put the capacitor back in yet. Let's plug it back in. And what's going to happen? It's moving that way again. But will it stop when it gets to the end? Yes! Sort of. Yes, it has. So it must be that capacitor that's gone down. Isn't that strange? I'll try putting the capacitor back in because it's going to be easy to remove it again. Because I don't know what value it is to replace it. Now, just for reference, that capacitor that I'm talking about is that one right there, labelled, if this camera will focus. No, it doesn't want to focus. It's better, sort of. C41. It's a surface mount capacitor, looks like about a 0603 size, which I've actually removed right now, but I'm going to put it back in and see if it still works, because that capacitor sits right across the output of that transistor. So whether that's causing the problem, we'll find out very shortly. Okay, capacitor C41 back in place. Let's reassemble it and try it again. Okay, we're all back together again. Let's plug in the power. And it's moving in that direction. Is it going to stop, guys? Is it going to stop when it gets to the end? Yes. Now, isn't that strange? I've put everything back together as it was before. Same optocoupler, same capacitor, and now it's working. That is too bizarre. The only thing I can think is that there was some heat-related issue with one of the devices, which has been cured by desoldering it and soldering it up again. If it happens again, I think I'll replace that capacitor C41 with something like 10 nanofarads or 100 nanofarads, something like that. But for now, I'm going to plug it in and see if it'll scan. Well, when I first started the scanner application, we got this message: release the lock switch, detach the USB cable and reconnect, close the scanner driver. Now, there was nothing wrong with it. The lock switch was released. I tried detaching and reconnecting the cable, and I was doing this while the scanner still had the glass off and the lid off and all the rest of it. So I put the whole thing back together, thinking that the whole repair had been a failure, it wasn't going to work. But once I put everything back together, put the lid on, put the glass back on, put all the sides back on, and reconnected it again, restarted the computer, everything works just fine. So success, even though we don't know exactly what the problem was.